Hello everybody and welcome back for the next lecture where I'll be talking about expressions. And we have touched up on expressions in previous lectures, but this time we will go into a bit more detail just to explain all the ins and outs with expressions, performance hits, and how to optimize them. So the main thing to be familiar with is that expressions have two forms. One are actually Python expressions, which are a bit more flexible. You can do a bit more with them. And then you have reference expressions, which are very fast to execute and should be used as often as possible. But in most cases, we need to do some string interpolation, or we need to do just something with Python. And that's where those Python expressions come in handy. And we have a few already, as I said. So in the output primary nodes, we have this expression, which is actually kind of a Python expression where you do some string replacements using the frame, the percentage method, and we are grabbing variables and all that. But we will do a bit more in detail. So the first thing what I want to do is make our life a bit easier while creating these AUV output variables. So as you can see, we have to type in primary up here, and then we have to type it back down there, and then in the output primary we have to type it again, primary up here and primary down there. So what we can actually do is we can make our lives a lot easier by just using an expression which actually reads the name of that node. So let me show you how I want to go about this. So the first thing is obviously to create an Arnold output channel define node, and let's just hook this up like that. And I want to give this a name. So let's say we want to create a specular one or something. Let's just do, or we just recreate the primary for now, which is just very simple to do. So the idea is to actually auto-fill in this name based on our node name. So what I can do, I can right-click the parameter name and just hit expression, and it becomes blue, and then you can click that little arrow and you can see there's like two quotes, and if I type something within those quotes, the expression is evaluated and the result is being passed as the name. So the first thing which we can do now is actually get the node name. So what you can do is get node name, which should output us the name of this node. So right now this doesn't work because we actually need to do something more. It does not know where to look it because get node name does not exist. So in order to get this to work, we will actually need to query the node which is called self. So self is actually the current node we are working on, and you would just type in self get node and brackets and control and enter, and now you can see we actually get like a weird interpretation of this node. And now what you can do is just type in dot get name, and then you can see we actually get the name of the current node. So what I can do now is if I just rename this, let's just rename this to let's just do AUV and type in specular. And now you can see we're actually that the channel name or the name of this is now AUV specular. But we want it to be, let's say we want it to be lowercase and just specular. So what you can do now, because this is a string in Python, you can just hit dot split. And let's say we just want to split it by a quote and then an underscore. And now we get actually a list back, AUV and specular. And now we always want to grab the last item. We just do a square bracket and type in -1. And now we get the result of that AUV underscore, but only the specular. And if you always want to make it lowercase, we can just type dot lower and do a function call. And now the specular is lowercase. And now to speed things up, we want to have it, I guess, in the layer name as well. No, sorry, in the channel name. Right now that's the same thing. And we want to type that in here too. So you can now run the same thing, but this will be a performance hit because it will need to query all this again. So what you can do instead, you can use a reference expression, which is a lot faster. And you would do that It's a bit different syntax, but the idea is the same. You would right click the channel, type in, choose expression, and instead of doing like a Python self get node or whatever, what you can do is just type in equals, and then if everything goes well, you can just type in name. And this is now just referencing the parameter from the top, and you can see it's super fast and it works very well. You could have also I think, no, you could not have gotten the node name, I think, because self is more, you need to use Python to actually get the name of the node. But this is now a very good way to do that. And obviously you would need to pass in the expression for specular. Let me just find that out. So the specular LPE would be this. So CRS, ignore the code and every light path after that. So this would be a specular setup for this AOV. And now we would need to create an output define. Is it render output or is it just output? Forgot about it. Render output define, and let's just connect these guys up. And obviously we want to have the same kind of logic here. So we edit this node, we rename this to output output specular. And you can pause this video now and just try it for yourself if you can set it up, and I will just obviously do it right now. So if you hit pause now, go ahead and yeah. So anyways, now we want to do kind of the same thing. We want to right click, hit expression, go in here, do self get node, and then we just want to type in get name. And now we get the name of this current node we're working on. We want to split it. We want to split it by the underscore, and we will just want the last item in the list, so we type in -1. And then the last thing is we want to make sure it's lowercase, so we can just force it to be lower. And now we have a working expression. And in the channel, we would need to choose that, so we can type in an expression again. And I'm sure we can just do like the same as we did before, equals, but this time the parameter is called output name. So we just type in output name and hope this works. And it does. So now this is all we gotta do. And obviously we would need to fill in the expression we did for our output path and just copy this and paste it as our specular AOV. So paste as an expression. And now we have an autocomplete, and now this is our AOV specular. We can change we actually had a specular here already. So let's just get rid of this guy and just plug in this with the tilde key, click and tilde again and click down there so it's connected, and just color that the same way. So now what we can do now very easily, let's say we want to create a specular indirect, so we can just copy this node and paste it, and now all we got to do is change our node name by hitting enter, and let's just call it specular indirect, or we can actually do an underscore. And now let's see what happens actually in direct. So now you can see our expression is not working as expected. We would like to see actually the name being not indirect but specular indirect. So now we would need to adjust our expression. Right now we are splitting by an underscore, and we're only taking the last item. So what we can actually do instead, we can do a split, but only force it to split it once. So if I in the split function do a comma and just type in 1, we're forcing the split to only split by one item. So now you can see it will only split by the first underscore it finds, and then it will stop the function, and then we will be choosing only the last again. So this is now our specular indirect channel. And now if I move this guy down and give us some more room here, you can see this is our specular indirect, and we would obviously need to do for our for the output one. So let's just copy and paste this, rename this to specular indirect, edit this, and change our little expression we have here on the top, and make sure this is only splitting it once like that. And now we have specular indirect, and everything just works as expected. Very great and very convenient to work with. This will help us actually to build our macro, which we will be doing as well. And then we have another expression for the turntable controller. So this kind of ties in a bit into the next lecture, where we'll be talking about different things, how to set up macros, and a bit more about switches and all that. But let's just start with this turntable controller. If you remember what we did here in that expression to actually animate our asset, in the T3D asset rotation, we have an expression. And this is actually looking for our input. Oh, it's actually not looking. We hard-coded the duration to be 200. So right now our output is 100. So if I change this to 200, the turntable would rotate the asset up to 100, and then for the last 100 frames, it will rotate the light. So you can see the gaffer rotation is happening here. And if I skip the frames, you can see how these expressions are being updated. And as I said, this is hard-coded currently. So the 200 is forced to be 200. So if I change my range to, let's say, 100, then it will not work, because we hard-coded that. So obviously what we want to do is we want to make this turntable controller very handy to use. And if I want to, let's say I want to change the length of my turntable length, right? So ideally I would hit edit here, and I have an option to change my duration. So let's just do that. So this kind of ties in into a macro already, but we will just be briefly touching the user interface to create macros, but we will have a more advanced lecture about this in general. So if I hit the wrench tool on any node, I can edit the user parameters. And if I right click this, you get this user drop down, and now you can actually add like groups, strings, other groups, strings, numbers, whatever what you have. You can add quite a few things. It's very interesting, and you can get very flexible. So I would like to create just a number for now, and we get a new parameter, and I hit the wrench tool, go to rename parameter, and just call this because we are in a turntable controller. I think if we just call it duration, it's very straightforward, and it's clear what it means, right? Obviously it's for frames, so let's just put in a default of 200. And now what we can do, I can just hit the wrench and say finish editing user parameters. So now we have this value on our top node. So whenever I hit edit, we can see the duration is 200, or I can change it to whatever I want. So obviously now we would like to read that value from within the controller. So I hit control middle click or control and enter to enter the group. And in our asset rotation, we would now need to adjust our expression. So if I right click this and say edit expression, we get a new window. So instead of hard coding this, what we want to do is actually find an expression. So let me first copy this out. So I'm hitting Control A, Control copy, and the first thing, I'm just replacing everything right now just to show you how this works. So how would we get a parameter which is on the top? So in Python, what you would do is type get parent, which goes to the top node, and then we would need to go to that parameter. So the first idea you would guess is you just type in duration, because that's what we called it, but it does not exist. The problem is whenever you add a parameter, it is added under a group called users. So you would need to type in user before and then duration, control and enter, and now you can see we get that value. And obviously, as I said before, reference expressions are a lot faster. So the syntax for that is a bit different as we had it before. Before we just were typing equals and then duration, right? This would be the example, but duration does not live on this node. So what you need to do is you need to go up a level, and for an reference expression you would almost do the same. You would type in equals, but then you would hit this little cap sign. It's on the 6, like this one. I'm not sure the exact name for this, but this little square number of or whatever. So you type that, and now what you can do is do a /, and then you type user dot duration, control and enter, and now this reads that parameter. And it's pretty similar to get parent dot user dot duration. But the first one is a lot faster to get that value. The problem though is you cannot combine reference expressions with Python. The bigger problem is now we have this whole loop here, or this whole expression, and obviously it is Python and we would need to do the whole Python thing. So wherever we see a 200, we can type in get parent like that, dot user dot duration, control and enter, and you can see the expression still works as expected. And then we have 200 one more time, and we just do the same, get parent dot user dot duration, control and enter, and everything still works as expected. So let's scrub and see if it still updates. So it only happens, the asset rotation is in the beginning of this. So on frame 1 it's on 0, and then it completes its rotation, and then at frame 100 we are on 360. So this seems to work just fine. Now let's just adjust the gaffer as well, and obviously this will be the same thing. 200 is get parent dot user dot duration, and let's just copy this as well. Copy, Control C, go to 200, double click that, Control V, replace that that number, double click 200 again, paste, double click 200 one more time and paste, and hit OK. So it's still on 0. Let's go after frame, and now you can see it's still rotating. It's in the negative axis, but that's what we had before. And on the last frame it's on 360. So now let's test it. If you are within a group and you want to edit the parent, you can actually see that we have the turntable controller name on the top here. So actually you can hover here, right click, and oh, you actually cannot edit it from here, but you can hover over it and just hit E, and then the edit menu is opened up. And now what we can do, we can shift and E over this asset rotation node, and let's just see if it actually does update. So if I change my duration, let's say we go up to frame 75, and I just change it to be maybe 100 frames duration, and now the whole thing changes. So this is expected behavior, because now our turntable ends at 100. So the first half is the asset rotation. So on frame 50 we are still on 360, but then on frame 25 we should be on 180, or it's pretty close to 180. And this is exactly what happens. So 50 it's on 360, and on frame 1 it's on 0, and then we can see that updated really just fine. So now we actually have a very cool turntable controller where we can just change our durations to work as expected. And one more nice thing to do is actually to hook up our top controller with another expression which is tied to the current out time. And we can actually do that as well. Let me just bring up the expression manual, and you can see now you have two options: Python expressions and reference expressions. And in the Python expressions you have lots of options to choose from, and I think in the bottom there's a way to actually get the project file, tempter, renderers. Let's see if we can actually find it. Project in time, project out time. So this is something we would need to query. So we would just type that in and see what happens. So duration, edit expression, and in here let's just type in project dot out time, control and enter, and now you can see the out time is tied to our project settings. Add-ons resort to project settings, which is a tab. If you don't have it, you can just click that drop down menu, go to project settings, and now the out time is on 100. So if I change this to be 200, you can see that this updates, and the whole internal controller update too. So if I change my out time to be maybe 1000, oops, 1000 there, you can see it updates at the bottom, and in the parameters it's on 1000 as well. And now you can see that my asset rotation is a lot slower, and it's just working out of the box. So this was a section about expressions. And in the next lecture, we will be continuing to build up on that and just extend the whole template and make it really working really great. So thank you guys for watching this lecture. I hope you enjoyed it. If you have any questions about the expressions or reference expressions, feel free to drop a question and I'll be happy to answer that. So thank you guys, and I see you in the next one.